Hello, Secure Code Summit. I'm very excited to be here today to present Containers Uncontained, or Docker security mistakes that I made so you don't have to. I start on a somewhat philosophical note. When we start learning about something new, some new technology or tool, etc., we start to develop mental models about that tool or technology. And those mental models are not really reality, but there's some simplified version of representation of reality that it's useful for us at a given moment of time. So when I was starting to work with containers, I viewed containers, or they seemed to me like something similar to virtual machines, but with pretty much instant start time. I viewed them as this strong containment field of a warp core that safely isolates whatever craziness is inside from the host that you're running your workload on. But that mental model very, very quickly evolved. And what I've realized in the end is that containers were created more as a convenient way of packaging and running software and not as a security tool. And isolation of workloads is not a core property, but rather a side effect of that technology. And so today I want to take a little bit of time to take you on a journey to explore the boundaries of that isolation that containers provide, and more specifically, where that isolation breaks down. To set the stage, I will mainly be talking about plain vanilla Docker. Think of a scenario where you run Docker Engine on a Linux host, though a lot of this will also be applicable to Docker Desktop running on your laptop. I mostly ignore any sort of orchestration layer that might be running on top of it. But in a sense, it is a layer on top of what I'll be talking about. And so a lot of the things that we'll discuss today still apply. And the first part I want to start with is networking. When we provision containers, what Docker does, it uses built-in Linux functionality, such as namespaces and C groups, etc., to do its magic, to basically create and run containers. When a network port is exposed from a container, then what Docker does is it adjusts IP table rules to forward the traffic so it reaches the container when somebody tries to connect to your host. With this in mind, this actually interacts in quite a surprising ways with IP tables configuration on the host. And this is what I want to explore first, and this is we're getting into my first demo. So in the first demo, we have a host on the left and kind of an outside sort of internet-based host on the right. On the left, we're going to start a container, and that exposes a network port. But as well, we'll check the firewall configuration and enable firewall and make sure that the firewall is configured to only allow SSH traffic in. So we run a container, we open a port, we see that the container works locally on the host as expected, but it also works on from the outside as well. So this is where, when we enable the firewall and check the rules, we see that only SSH traffic is supposed to be allowed. With the firewall enabled, the container still works locally, but what's more surprising is from outside, it also is still working. This works absolutely the same when you're using Docker Compose. So Docker Compose is just another way of starting the containers. So if we do basically the same experiment in Docker Compose, we will see absolutely the same result. So here as well, we have firewall enabled, only SSH allowed. We launch just a simple single container with port 80 mapped to it. And from outside, we can still connect to it and get a response back. This might be surprising, but this is not the only kind of sharp edge that we have with regard to the networking. Another misconfiguration that I've encountered from time to time is related to port mapping in Docker Compose files. So Docker Compose files allow us to run multiple containers that work together and basically interact and connect to each other to ultimately provide some application to the outside world. With Docker Compose, all the containers within the Docker Compose file can talk to each other by default, and they can do that using container names within the Docker Compose definition as the host names to connect. So in that regard, if you have two different containers within the same Docker Compose file, you don't need to map ports from the outside to enable communication between those two containers. So this is my next demo. Basically, we have, this is the Docker file that I'm going to run. We have two containers. One is web, one is Redis. And from the web, there's no ports mapped to the outside world. So these containers just should run locally, not accessible externally. But even with that, the web container tries to ping the Redis database, and we'll see that ping is successful. Same Docker Compose file that I was showing on the slide, starting both containers, and we'll be able to see the response from the Redis container to the process that's running in the web container. The next thing I wanted to cover is when we launch containers, they're launched in this kind of virtual network. And if you launch multiple containers, by default, if you just use Docker, not Docker Compose, all of those containers will be running in the same virtual network. What that means is those containers are able to talk to each other using the private IP addresses. And this is kind of the next demo that I want to show is we launch one container, we get a private IP address of that container, and then we launch another container and make sure that the second container can reach the first container using that private IP. This is slightly different from the Docker Compose use case. So Docker Compose, by default, every Compose file, every stack that you deploy to Docker will get its own virtual network. So within the same Docker Compose file, all the containers are able to talk to each other, but across different stacks, the containers are not able to talk over the virtual connection because it's different virtual networks. We've sort of covered bridge networks mainly. Host networks work differently and might not be affected by these settings, but this is not likely what you want to do with your containers because it brings in other problems with it. So to sum up, Docker Compose creates bridge networks per stack for isolation. If you want to do any sort of firewalling, so if you expose ports on the containers and don't want them to be accessible externally, it's probably best done from the outside of the host using security groups and cloud providers or something like that. If you have to do it on the host, you can check the Docker documentation. It sort of outlines this use case. There's a new iptables chain that Docker creates when it's installed. It's called Docker user. And that's the chain where any of the rules that you want to be affecting containers should go into. All right. With that in mind, my next kind of topic is around process and file system and breaking down of isolation there. The first thing I want to cover is Linux capabilities and privileged containers. So Linux capabilities are a way to give some processes or users access to functionality that typically is limited to the root user on the Linux box without giving them the full root permissions. And some of those capabilities are quite dangerous, especially when applied to Docker and containers and isolation of the containers. So because Docker is essentially using Linux primitives to kind of provision containers and to work, what's happening is that all the containers share the same Linux kernel that's running on the host. That means that if a container is giving privileges, for example, to install a kernel module, then basically that module will affect the whole host. And this is my next demo. We're looking at a container that is started with privileged flag, which gives it ability to load kernel modules, and we demonstrate that that will easily result in a container escape. So right now we're on the host. We check that there's no file called Uncontained in the root directory. We launch a new container with the privileged flag. That's the one that gives it, that breaks some of the isolation and gives it access to load kernel modules. From within the container, we load this malicious kernel module that will basically create that uncontained file in the root directory, and it will also dump the user ID that it had access to. And we also see by listing the kernel modules that we see that malicious kernel module was loaded. So essentially what this means is any container that was started with privileged flag or can access some of the more sensitive capabilities on the host, have given those capabilities, ultimately we'll be able to escape and we'll be able to get full access on the host and all the other containers on the host as well. My next demo is related to the use case where Docker socket is mounted to the containers. So Docker socket is a way. So if you think how Docker works internally, so there's a when you install Docker, it installs and starts as a service something called Docker daemon, and that's the service that does the heavy lifting. That's the service that does all the work. And then when you interact with Docker CLI, what's happening is that the Docker CLI ultimately talks over the Docker API to the Docker daemon and instructs it to do something. That communication by default happens through a local socket on the Linux host called docker.sock. The thing is, anybody who has access to the Docker sock can interact with Docker daemon, and that ability to interact with Docker daemon is essentially equivalent to privileged access to the host. And this is also well documented in Docker documentation, but one kind of case where this is essentially important, especially important is when that socket might be mounted into a container. We might ask, why might we want to have the Docker socket mounted to the container? The thing is, sometimes you want to be able to build images from within the container and do things like that and just interact. There might be legitimate use cases for a container to interact with Docker daemon, but just it's important to understand that that creates, that breaks the isolation of that container and that makes that container a privileged container and basically being able to access the host. So the demo here is that we start a container with a Docker socket mounted to that container. And then what I'm doing is from within that container, I start another container. I download Docker CLI and I start another container and I specify privileged flag to it. And essentially what that means is we're now have broken in isolation and have full access to the Docker host. So we ran a new container with privileged, also with full access to the network host and host file system and process IDs. And from within that container, we're essentially on the host, so that we've escaped from the container to which the Docker socket was mapped to. So to sum up, Docker socket allows privileged access to the host. Privileged containers have a lot of their isolation, most of the isolation mechanisms disabled, so it's equivalent to having full access to the host. And there's also certain sensitive capabilities that it's not a good idea to give to containers, or if you do that, just be aware that creates avenues for container escapes and privilege escalation. So some of those capabilities include sysadmin, sysmodule, that's the one that allows you to load kernel modules, process tracing, and things like that. All right, last kind of topic that I wanted to cover is container images. So where do container images come from? Ultimately, they're built from a specification called Dockerfile. And when that happens, the structure of the container image is layered. So essentially, each line of the Dockerfile will correspond to a layer in the container image. And although when you run the container, you see kind of the final outcome of combining those layers, but all of the layers are present in the image. And so what that means is if at one step I drop some files with sensitive information like access keys, maybe I want to pull additional files from GitHub, or maybe I want to access secrets in my cloud environment or something like that. And then at a later step, I remove those sensitive files or those credentials. Those files are still there if that happens in two different layers. They're not visible from the running container, but if you pull the image and analyze the image, you will be able to see all of that content in there. This is my last demo that kind of shows, this is based on a CTF challenge that we ran at Besides Vancouver several years ago. And it's basically finding a hidden flag within a container. And it's exactly what I was talking about. So we have this image called Docker Peekaboo. We run the image, we see there's no flag in that container present as is, But if we open that image for analysis, we see that at one of the steps, that flag file was copied into the image, and that at a subsequent step, at the last step in this layer kind of structure, that flag was removed. So in the running container, it's not present. But when I extract the image and extract that layer where the flag was copied, I can access that sensitive information, and I can access that flag. So here we're extracting that image. We're kind of finding the right layer, and then we can access the file from within the hidden file from within the image. All right. That's basically all I had. Just a quick recap. Containers are not strong security boundary. If you want strong security boundary, just using containers is not enough. At least you need to do something like virtual machines, or maybe use some additional technology that kind of gives you container-like interface, but actually provides stronger isolation. Things like kind of mini VMs, and there's other things like that do that. Containers break in many ways. So networking is a sort of not finicky, but interesting component that doesn't always work the way you might expect. And also process and file system isolation are easy to break if you add things like additional capabilities, or start privileged containers, or map some sensitive files from the host to the containers. And the container images have layered structure, and you have to be really aware of that when you build your own containers, and make sure that you don't have secrets hidden within the layers of the container. That's all I had for today. If you're interested, grab slides. That's the QR code on the left. If you want to continue conversation, feel free to connect with me on Blue Sky. I would like to say a huge thank you to Antisyphon Training and Black Hills Information Security for putting together this amazing event. And if we have time, I'm happy to answer questions.
I see one that came up here already from Roswell. Are these concerns also present with other containers other than Docker, or are they all equally vulnerable?
Ooh, they might and they might not be. A lot of this is Docker specific. So for example, Docker socket is a Docker thing. Other containerization technologies might have similar kind of capabilities, the way they work, but they might not. So most of these would be Docker specific, but kind of if you take the concept and try to apply it to different containerization mechanism, it might still be applicable. There's some containerization technologies that don't have that running daemon, because the Docker daemon is running as a privileged process, and kind of that's what creates all the magic. There's some containerization technologies that basically run as the user that started the container, that definitely gives far better isolation than Docker, but it also comes with pitfalls, like obviously interoperability. And if you want to go to any sort of orchestration, a lot of those basically depend on very specific containerization runtime. Like Kubernetes is using containerd, and has been using Docker previously, and things like that. So you don't always have a choice, but there's some other things like Podman, I know, works quite differently from Docker and might not have all the same issues. So it's probably not one for one applicable to other containerization.
Thank you, sir. Linux Girl has a question here. There was a sleep 1 in the script. What if it wasn't there?
Trying to remember what script that was. Oh, so that might have been when I was demonstrating the two, and correct me if I'm wrong, but if it's the one where I was demonstrating two containers in a Docker Compose, kind of talking to each other, there was a sleep to just, don't ping constantly, do a little bit of delay between them. So ultimately, containers are processes on the host. There's some isolation around that process, but ultimately at the end of the day, it's just normal process. So whatever is running in that process is basically running on the host. So the reason the slip was there, it was for basically not flooding the screen with the messages and kind of do a delay between them. But ultimately, it So in some cases, what I've seen is you start sort of a dummy container that has bash, and it will have as a main command slip some big number, and then you basically can exec into that container and run some other commands. In which case, that sleep is sort of used as a placeholder to keep container running and not kind of die, because when that process, that's the main process of the container, dies, the container is killed or a container is stopped. So anything else that might be running in that container will also be stopped when that main process exits. Not sure if I answered the question, but clarify if I haven't.
Awesome. Thank you, man. Here's a question from Ricardo. In the past, I got detection of misconfiguration inside a Docker file that, according to the SAST scan, ran on root level privileges and had a copy of all command to build a container. It was discarded because that was used locally, but I wonder if this can be a false positive or if there is a real attack vector on it.
Yeah, that's an interesting topic. So a lot of containers, when in most cases, the user ID that the process within the container is going to run is defined by the Docker file. You typically can change it later, but oftentimes that will result in the container breaking because it expects that specific user ID. So the recommendation there is to, even though it's kind of containerized and isolated, to not run things as root within containers. I think where it matters is kind of, it doesn't give you by default any more access to the host than the container has, but it matters in cases where there's some specific CVE for privilege escalation, or maybe a kernel exploit that might require root access on the host to work, and so it kind of reduces your attack surface for that container. The other thing to look into if you're concerned about that issue is user namespace mapping. So you can tell Docker to basically say, even if container is requesting root, you use some fake user on the host to run that container, but impersonate it to the container so that container thinks it's root, but it's actually not on the host. So there's kind of magic that Docker can do to map that access. But ultimately, it's not an immediate vulnerability if you're running a process within the container as root. In fact, a lot of the containers that you will just pull from Docker Hub, that's how they work, and it's really hard to change that without kind of a lot of additional work and testing that nothing broke. But it's more of a defense in depth mechanism. It basically slims down the attack surface of that container. So if something were to get into the container, it kind of gives less possibilities for those process or like malicious actors to escape.
Docker's fun. It's a fun
Yeah,
little
yeah,
like tool to play around with. I was always like
yeah.
really big into virtualization. So when Docker started becoming a thing, I was like, oh, this is interesting. This is a whole new take on virtualization. Like yeah, a whole new learning journey there.
Definitely, definitely. I personally I hate installing like big software with a lot of dependencies as kind of to the host. So I've been running a lot of things as containers, and I've been preferring to do that. So for example, you can run Kali Linux as a container and do it on your Mac machine. So it's definitely gives a lot of versatility and kind of isolation in terms of just even installed libraries and broken dependencies and conflicting dependencies and things like that.
Are you a fan of Docker Scout?
I haven't used Docker Scout much. It's definitely a useful tool that we should be using. There's other open source, or not open source, but at least free tools that run kind of scans on containers. Trivi is the other one that I've used previously. There's also one called Grype. So ultimately, like, containers are just like other software. So there's going to be dependencies and CVEs in them. And so there's a lot of tools that you can use to scan the containers for CVEs, either like scan your whole private repository if you have one and you're building your own images, or just scan running containers or images for running containers to see if there's any patches that need to be applied. Patching for containers is interesting because containers are meant to be sort of immutable in a sense that you don't like log in into container and start applying patches. What you do is like you kill the existing container and start a new one using a new version of the image and basically remap all the like data and port mappings and whatnot into the new container. So it's definitely different, and it's a little bit of adjustment from traditional infrastructure patching, but it's still a thing. So scanning for CVEs and updating container images and containers, definitely one of the hygiene items that we should all be thinking about.
What's your preferred containerization program, or do you still prefer virtualization due to the weakness mentioned in this talk?
No, I'm using containers quite a bit. I'm using them personally to like run tools and whatnot. I wouldn't say I have a preferred kind of containerization technology. I've been playing with an open source tool called Colima lately, and that's kind of on a Mac that gives you command line kind of capabilities to create a VM and start containers there and have like Docker CLI that's linked to that. So Docker Desktop, it's free for personal use. It's paid for commercial use, but it's still like it's probably the most advanced and most feature rich Docker kind of client on for desktops. And it has a lot of things now like extensions and development environments that mainly they've been lately with Docker Desktop been focusing on developers and making their life easier. But it's also useful for others. Like Docker Scout is one of those things that is included in Docker Desktop, but you'll have to find some alternatives for other containerization technologies. But for isolation, definitely go with virtual machines or like micro VMs. AWS has open source, I think, technology called Firecracker that kind of provides sort of micro VM type capabilities and isolation. Don't just use containers if security isolation is super critical for you.
What do you find to be Docker's biggest weakness?
Ooh. Uh, I'm not sure. I'm not sure how to answer that.
Yeah, no problem. Problem. Why do you think people fear using Docker so much? It's almost a dev industry gripe.
Um, I don't think that people fear using Docker. And I think that the reason it's more popular within dev industry is that it solves a really important and really challenging problem for devs. And that's like when I was talking about like Docker is software packaging technology, it shows. Um, it basically allows you to reliably and repeatably run things across multiple different environments that you don't need to think about kind of making them all the same. So you can build a container and run it locally on your laptop. You can run the same container image on a server, and you can run the same container image in Kubernetes or some other orchestration technology. And that is the core value proposition. It packages all the dependencies and all the requirements into this one thing that you can then go and deploy to different places and easily test and easily run in production. So from that perspective, containers are great. I think like security people should use containers more. As I said, I've been using containers to even just run security tools locally. Like you want to run nmap, you can run it in the container. You don't need to install it. It also gives you kind of easier path to upgrade, no like broken dependencies or conflicting dependencies. It's just cleaner way to use things. And so that's ultimately the whole objective of containerization, and that's the problem that they solve.
Hmm. What about LXC or LXD or Incus? Incus?
Mm-hmm. I haven't played much with those. Ultimately, it's important to understand that definitely the nuances are going to be different, but the base components are going to be the same. And those base components are so um, the standard, and I'm now blanking on the name, it's like OCI or something like that. There's a standard on how images are packaged. So when you upload an image into some private repository, and when you download the image from Docker Hub, the format of the image, there's a standard on that, and a lot of the containerization, if it's not Docker, containerization technologies will use that standard. So you'll be able to pull the same image regardless of whether you're using Docker or some of the other containerization techs. So that's the first piece that's often the same. The second piece that's often the same is all of them maybe somewhat different ways, but they're using the built-in capabilities of the Linux kernel to sort of create this notion of container. Container is not a thing in Linux. It's a combination of different things combined together to kind of create this illusion of isolation, and that's namespaces, C groups, and things like that allow you to kind of chuck this one process off to the side and make it not break other things or make other things not affected. And so from that perspective, LXC, LXD will use the same namespaces and C groups, probably in different ways. The CLI is likely going to be different. But fundamentally, containers are processes on the host with some isolation on top of it to make them not conflict with other things on the host.
Awesome. Thank you, sir. We're getting close here on time. We got like one more question here, and then we'll get kicked off to the next one. The last question here: does running nmap and Docker slow things down due to the layer of abstraction? Is it more noisy or the same?
Shouldn't be more noisy. It definitely will be somewhat slower, but considering that that layer of abstraction is purely on your laptop, and if you're scanning hosts, especially on other networks, that kind of overhead is going to be negligible. It's even less when you're kind of running on Linux. So the difference between Docker engine running on Linux and Docker desktop is Docker desktop will create a virtual machine on your computer, on your like laptop or desktop, and then the containers are not actually running locally. So even Docker desktop on Linux, this is how they work. It creates a VM, and containers are running on the VM. They're not running on the host. So that creates a little bit more overhead. But if you're running containers on like straight up using Docker engine and running them on a Linux server, that overhead will be negligible.
Awesome. Thank you, sir. If anybody has any other questions, what's the best way to get a hold of you?
Probably that QR link to Blue Sky, Airman 604. That's the easiest way.
LinkedIn, is that an option too?
Sure. Yeah.
All right. I
Just
had your
look me up by
LinkedIn
my name.
profile.
The name is unique, pretty unique. So
I put it in the
easy
chat
to
so
find me.
everybody could see it. So
Yep.
they can all connect with you there. Thank you again
Absolutely.
so much for being here. I appreciate you sharing your knowledge.